Good afternoon. My name is Mike Corley, and I'm with Quanterion Solutions. And today I'd like to share with you a Quanterion developed tool called STIRCAT, or the STI Retrieval and Cataloging Assistance Tool. Just a little background. Here at Quanterion, one of the things that we're chartered with is the requirement to discover, collect, and submit DoD-sponsored technical, DoD-sponsored scientific and technical information, or STI. Now, this information is uploaded where it's ultimately made searchable and accessible to the DoD community it serves. So that's essentially any technical work that is sponsored by the government that carries with it a paper trail. That's technical reports, conference proceedings, journals, any contractual work that's done with an organization where there's a technical reporting process. The idea is all that information makes its way back to a common location where it's accessible to certain DoD organizations and individuals associated within various methods of distribution A to F and so forth, that sort of thing. But the reason I bring that up today is that prior to STIRCAT, this is a relatively manual thing to do. So a lot of the research that's performed in the industry and community, that doesn't necessarily make its way back into DoD spaces where it's ultimately searchable and accessible. One of our customers is chartered to do that, and therefore we are chartered to do that on their behalf. And what we do prior to STIRCAT is we would go out and manually look for some of this information, and we would review it to see that it fits in a certain technical focus area, and it matches essentially all the requirements or the criteria as to be valid DoD-sponsored STI. Is it sponsored by the government? Is it copyrighted? Within those constraints, and we would record this information, and we would ultimately submit it where it would be, again, accessible. But prior to STIRCAT, this is a very manual process. You're going to essentially go out and look for conference proceedings and things of that nature, and manually record the metadata components, authors and sponsoring agencies and performing agencies, all those kinds of things, publication dates, and then make that information, catalog it manually enter it in, and then submit that information so that it would be ultimately accessible. So in an effort to really save on the resources of our personnel, because it's tedious and error prone, we developed a tool to automate a lot of this process, and that tool is called STIRCAT. So essentially what STIRCAT does for us is a number of different things, but I'm going to demonstrate a couple of factors of it for you. The first thing is it provides a script-based orchestration facility that allows different scripts to be written, each designed to extract content and metadata from online accessible data sources. So it goes out and acts on behalf of the user, does searches, and it catalogs those searches. It pulls them back and extracts their metadata, and then allows that metadata to be presented back to the user so that you've really automated a number of steps in this workflow. Okay, so instead of manually looking one at a time, you're getting back large quantities, and instead of manually typing this the metadata entries in and following the workflows of the review, a lot of those steps are automated. So the essential impact of STIRCAT is to really enhance the efficiency of our folks, our domain experts, that are going out and searching for, collecting, and cataloging this information. So without further ado, I think I can just go ahead and start to see some of that. So this is the main STIRCAT interface you see here. And like I mentioned, it has a script orchestration facility, and we can, essentially any facility that you can write a script for that conforms to a convention, that's a data format convention, and a metadata naming convention. As long as you adhere to that convention, then any script can be plugged in and orchestrated. So I'm going to pick Semantic Scholar as an example, and I'm just going to type in a search like I would if I were to go to Semantic Scholar. I'll type in machine learning, and maybe I'm interested in a government organization that sponsored it. So I might do something like that. Okay, so machine learning DARPA. And I'm going to hit the search button in a moment, but what I'm asking STIRCAT to do is to collect for me 10 documents. Now I can specify a very large number. I could say, collect for me 100 or 1,000 documents, which we do commonly. And also, every search is different. Some searches will return potentially many, many pages, up to hundreds of pages of results. So we can be flexible and specify what page number we want to begin with in a search. You know, we have to have a little bit of insight knowledge about that search, but we have that flexibility. Page load retries are to basically accommodate any connection-related errors or little blips that might occur as we're making requests on these web resources. So now all I need to do, I can also label this. I can give this a category. And so I might call this software engineering. And now what I'll do is I'll go ahead and hit the search button. And what you'll see that do is it'll pull up in a browser window Semantic Scholar with that search, and it'll automatically go and search that and pull those results. And what it does when it pulls them down is it hashes the content. It generates a hash, and it uses that hash to determine whether or not that information or those, here's an example, it uses that search, that hash rather, to determine if that's already been downloaded by a previous search, so that we're not handling documents more than once. We're deconflicting duplicate entries, in essence, is what we're doing to keep track of, because you certainly don't want to take down information that you've cataloged and then pull that again up and pull that again in subsequent searches. That wouldn't be an efficient use. It's one of the challenges of this process prior to a tool such as this. Now, we've asked STIRCAT to return for us 10 documents. So it will work very hard to do that. It'll go to these web sources and it'll pull a page of content, and it'll continue to go through and pull from subsequent pages until it can satisfy. You see it continually pulling up the screen. It tries to satisfy that requested number, 10 documents, or it'll fail and return whatever it can get. So you can see it's at 9. And one thing it does is it analyzes that metadata as it pulls it, and if the metadata is insufficient, it'll reject or it'll throw away some of those entries that don't. So for instance, a lot of them didn't have valid PDF documents, so it just throws those out. In some cases, the documents, as I mentioned, were already logged, and it tells us here. It uses that hash to tell us this is a document that we've already pulled in a previous search. So this is a really nice way to automate that process. So here you can see I pulled down 10 documents. Now if I just go ahead and view one of those with the metadata, what it does is it takes that metadata and it just, whatever metadata it captured, and it just shows it right back to me, okay? So I can do certain things. You can see it pulls the abstracts, it pulls the titles. Let me go and pull another one up here, just give you a sense. So you can see if there's any information. Now it tells me information. It looks for DoD agencies like DARPA, so I can click on these and I get a little context window where I can see in cases where that keyword is matched. And that's very helpful for very quickly being able to determine what government organizations are involved in a particular piece of technical work. Is it sponsored by a certain government agency, or did a certain government agency participate? Okay, and so you can see right here that this says, I just clicked it on the keyword funded, and it says very quickly, DARPA and NSF use these contract numbers, and they funded a portion of this work. So this is a valid document. So I would just go through and mark it with the appropriate distribution levels. And in many cases they have keywords, but in some cases they don't. That's important for indexing. This particular tool has a basic topic modeler that I can just use the generate keyword, and I can click on that, and that'll pull back and do some keyword generation for me. Okay. You know, sponsoring agencies, it pulls out whatever it can find. Essentially what it does is it uses rules. These are statically written rules that get applied that it uses to pull this information out, some of this information out and make it accessible. But a lot of it comes directly from the website source that was pulled by the script. So in the case that we just saw, the script that pulls from Semantic Scholar is returning much of this metadata, like the title and the abstract and many other pieces. So this is really a tool, just in summary, that allows us to automate the searching of scientific and technical information that's out there in various web accessible repositories. And it provides also this metadata analysis facility that again uses rules, and soon we'll use some machine learning assisted support to extract multiple levels of metadata. So I think that's it. I'll just comment that I can vet this information as I review it. I can say I can exclude it if it doesn't fit certain STI requirements to be qualified as valid STI. And that'll generate a hash, so I'll never see this again in subsequent searches. And all this information is stored in a MongoDB database. It's a perfect fit for this kind of database that's document-centric, okay? And it's all exposed to a REST API. And that's what you see here over in this window here. So all of the interaction with this is, after the fact, is performed via a REST API. So the lookups that we want to do on documents and subsequent searches and so forth are all there. So just if you have any questions, I want to leave our contact information. You can contact myself or Mr. Cully Patch at these particular points of contact. And I thank you for your attention, and I wish you a great day.